This is the 5th video of a 7-video series on factoring, non-monic trinomials. As we know, a trinomial is something with 3 terms. Here's an example of a trinomial, and what makes it non-monic is because it's not monic. Monic meaning the leading coefficient of 1, non-monic meaning the leading coefficient is not 1. And when that number in front of the quadratic term, the quadratic coefficient is not 1, factoring can be a lot more cumbersome. There's 2 methods that you can use for a non-monic trinomial. One of them I'll show you first is called the grouping method, and the second one I like to call reverse FOIL, because it's essentially what we're going to do. Well, let's look at the first method first, the grouping method. Now you may recall that in the grouping method, which was a prior video on factoring, you need 4 terms to use the grouping method. Well, this problem only has 3 terms. Well, I'm going to show you a clever way to turn it into a 4-term problem and make it factorable by the grouping method. Let's recall some vocabulary. This is our constant term, our linear coefficient here, and our quadratic coefficient. And we're going to use the coefficients only in this very strange process you're about to see, and we're not going to pay any attention to the x squared or the x. So you take your linear coefficient, and then for no apparent reason whatsoever, you multiply your quadratic times your constant. 5 times 24 in this case is 120. Now you've already got to be thinking to yourself, none of this makes any sense. Well, it is strange. I'm showing you a process that mathematicians have developed to factor non-monic trinomials. What I'm not including in this video is why it works. That's a whole other story, and omitting that, this is one of those blind faith procedures that sometimes we just have to follow in math to get a correct answer. Okay. So for whatever strange reason, because the mathematician said so, I did 5 times 24 is 120. Now what mathematicians in prior generations have figured out is that we need to guess and check 2 numbers. And those 2 numbers have to, 1, multiply to be 120 in this case, and 2, they have to add up to negative 43. Again, why this works is a completely different story than what I'm telling here. Okay, well, let's start with what numbers multiply to make 120. I just have to randomly guess numbers and see what works. By the way, I could start by asking myself what 2 numbers add to negative 43, but that seems like a lot more possibilities than the number of ways to factor 120. So let's take the number 120. It could be positive 120 times positive 1. It could be positive 60 times positive 2. It could be a lot of things. Here I've listed every possibility on how to factor 120 in terms of a positive times a positive. But I doubt any of these will meet my objectives, because if you look at the red, we want numbers that add up to negative 43. None of these add up to a negative at all. So I thought, well, why don't I make them all negative? Their product is still positive 120. A negative times a negative being a positive, of course, but maybe one of these will add up to negative 43. So to check, I add those, I add those, I add those, add those, add. Okay, I've added them all up, and what should be jumping out at you right now is the negative 43 that I was looking for. So what have I achieved? I have achieved my guess and check numbers. Notice the upper right corner of the screen, I was looking for 2 numbers. And I have found that those numbers are negative 40 and negative 3. Of course, what I haven't told you yet is what any of this has to do with factoring this trinomial. But that sort of ends phase 1 of this problem. So I found these guess and check numbers that meet certain conditions. And now I'm going to use them in the following way. I'm going to take my linear term, not just my linear coefficient, but the term itself, including the x. Now, this is the first time I'm using the variables in this problem. I'm going to take my linear term and split it as a sum of two terms. Now, this is weird thinking. I think we could all agree that the two terms in red on the bottom combine to make the one on the top. But why would I want to go the other way? Why would I want to turn one term into two terms? Because if I then include my quadratic and constant terms from the original problem, I've now turned this factoring problem from a three-term problem, or a trinomial, into a four-term problem. And as messy as that seems, that's going to allow me to factor this by grouping. Okay, if you haven't seen the factoring by grouping video, it's video 3 of 7. If you haven't seen that and you're not familiar with the process, I recommend going back and watching that before finishing this video. If you're comfortable proceeding, we'll do that. Here's a reminder of how grouping works. You group them into pairs of two. You take the first two terms and you factor something out. You factor the GCF out of the purple in this case, which is a 5x. You'll notice 5 and 40 are both divisible by 5, and I can factor out an x because x to the first is the lowest power of x. Factoring that out gives me this quantity. And now looking at the last two terms, I can factor out a negative 3 there. I could also factor out a 3, but it will make it easier to factor out a negative 3 for reasons you'll see in a minute. By the way, notice the 8 is negative there, which is consistent with the fact that negative 3 times negative 8 is 24. Okay, continuing with the grouping, you may recall, hopefully from a prior video, if you saw it, that when you're doing factoring by grouping, these two will match. Well, if they don't match, then the problem isn't factorable. But chances are you've been given problems that are factorable. So count on those things in blue matching. And you may also remember that when we factor that out, we only get one of them. And the GCF of each pair is used to form our second factor. That completes the grouping, and it completes the factorization of this problem, and method 1 for non-monic trinomials. Now, method 1 is pretty straightforward. You can follow a procedure and eventually be guaranteed to get an answer, but I think the procedure is somewhat lengthy. And I myself am partial to what I've called the reverse FOIL method. That's not an official name for it, but it's a fitting name, as you're about to see. So even though we've done this problem already, let's do it again a different way. Here's what's going to happen. In my experience, 4 out of 5 of you watching this video right now are not going to like this second method. But 1 out of 5 of you, in my vast teaching experience, is going to say, oh, that's so much better than having to memorize some strange method. In fact, I've got to be honest with you. Right before I produced this video, I looked up the grouping method again because it will never stick in my brain. There's something about it that is just too much information for me. Here's the reverse FOIL method that I am partial to, as you can tell. So we've got our quadratic term, our linear term, and our constant term. Now, if you've seen any of my videos, you know how deliberate I am with color. Why would I choose such a light gray for the linear term? Because on the first step of reverse FOIL, you pay no attention to the linear term. Pretend it isn't there. Set up a FOIL problem, picking any two things that multiply to make the quadratic, and any two things that multiply to make the constant. Now, when you make your guess in the reverse FOIL process, you pay no attention whatsoever to the linear term. you make a guess based only on the first and last terms. And then you do FOIL. Now I won't belabor every detail here. You can pause the video to see the details if you'd like. But the point is, I'm factoring a trinomial, therefore my guess, if correct, should multiply out to equal the original trinomial. Well, it almost equals the original problem, except the middle terms don't match. That doesn't mean this is unfactorable, it just means my random guess was wrong. And when your random guess is wrong, you go back and guess again. Here's my second attempt. All right, starting over. Pick any two things that multiply to make the quadratic term. These are the same two I picked last time because it doesn't seem like anything else would work. But this time I'll try something different for the 24, and I'll try -3 times -8. Notice when you do FOIL, pause the video if you need to see the details. When you do FOIL, by luck, not only do the middle terms match, but the entire thing matches. We have found something that when multiplied out equals our original problem. Now, you saw me in this video get it right on the second guess. One of the drawbacks of the reverse FOIL method is you might not get it right until the 7th or 8th guess. So for you to use this method, you have to be comfortable with doing FOIL over and over again. And if you are, it's a better method, I think, than the grouping method, but I'll leave the decision to you, of course. There's our final answer. So you've got two choices on how to factor a non-monic trinomial. Choose the one that works best for you. And that ends the 5th of 7 lessons.